Oh, Michael, go ahead, sir.
So I have something I want to share. Let me see here. This. Okay, I have this. So when I did my presentation, there was a discussion a little bit about a question of how do I know that the gravitomagnetic field is independent from the electromagnetic field. And so I have some actual data that I was going to explain to show this. Now, what I have here is a image. This is the image of what it looks like. It's a disk with a sensor reading back. Now, this is up here on the right. Upper is what's called a magnetic force microscope image of a track written on the surface of the hard drive. You'll see these these smaller little bits here, they're called. That's actual data written on the drive. And then up here, there's these other bigger giant bits, and that's what's called a servo track. A servo track is kind of like the grid, so that you know the location of the data in space on the surface of the disk. It's kind of what aligns the data that you're looking at. Now, over here on the left is a atomic force microscope image of our nano pit, which is 10 microns by 10 microns squared, and it's about 2 micro inches. There's 25.4 nanometers per micro inch. That's like 51 nanometer deep. And so what happens is, going back to this one on the right, you see the written track. When your read head is reading back actual data, what it looks like is this below. It's like little AC signals written on like this. It's not really there. It's just a virtual thing. It's not like a physical thing. And then the reason that I'm showing this is because when your hard drive, when you first set it up, it's looking for like defects. And the way it finds those defects is it writes these little pulses, and then it goes back and it looks for where the pulses are missing. And now in this case, this is the actual readback signal from this nanopit. And you see that the pulses disappear. So your hard drive has a little algorithm on it that'll map out where the defects are, and it'll avoid that when it's writing data. Now, this image here on the left, lower left here, is the same readback, but instead of having these data tracks here, it's like this region in the middle here where there's no field direction. So it's what we call the erased portion of the disk. And the next, this will be important for you to understand later, because the way they do that is they apply a DC bias to this little coil, and that erases it that direction. You can also change the bias the other direction. So even though it's erased, it still has a polarity. So, but what we have over here is these little signals here are magnetic induction signals from the defect edge, and those occur at the speed of light. And then this little pulse in the middle, the broader pulse, that's the gravitomagnetic induction signal. Now I'm going to go over here and show you what's going on. So now there's these, as I explained, when you're erasing it, there's these two little wires, and we can switch the polarity, but that shouldn't affect the gravitomagnetic signal, because that's dependent on the presence or absence of matter on this as it moves in space-time. And so what we see is when we flip the polarity of the wires in the erase direction, watch what happens to these two little pulses here. They flip, but the gravitomagnetic signal is still the same positive direction. And that's because electromagnetism and gravitomagnetism are not the same thing. They're independent from each other. Okay, thank you. That's I'm done. So I hope that shows, basically that's proof that it's not the same thing, because you can't erase the gravitomagnetic induction signal. Any questions?
Hi, Michael. This is the Gravity Alchemist. Anyway,
wasn't that you that was curious about how I knew it wasn't electromagnetism?
no.
No.
No, basically, I used to work in a TV station. I had an unusual career as an insurance agent, blah, blah, blah. But as soon as I dropped out of high school, I went to work in the engineering department at a local TV station. And we had these machines that would count dropouts on videotape. We use these big 2-inch videotapes on RCA machines, and it would count the little specks that drop off the tape. It kind of reminded me of that. And then we'd run the tape through the dropout machine.
These are magnetic tapes?
Yeah, they're magnetic.
Yeah, it's the same. It looks the same on a magnetic tape. And you can actually measure gravitomagnetism from a magnetic tape, but where it comes from is the little holes. You know how it has those little holes in the side? That's where the gravitomagnetic signal comes from.
And that's why, I like listening to these these presentations. I'm learning a lot about at the quantum level or at the small particle level, because I'm mainly mechanical. I'm mainly a Newton time clock type of guy, but I know enough about some of these other things to be dangerous. But the idea I am working on, it's what I'm it's got to be different than electrogravitics. Gravity's got to be different. But anyway, I just thought I'd throw that out. I did start. Go ahead.
I said thank you.
Okay. Hey, I joined. Well, I am joining tomorrow a laboratory, a maker laboratory. I put this challenge out on my website for people that anybody wanted to join me. If I get a patent, that I would share with them anything that my idea comes up with. But no one's joined me. I think I could put gold.
If you do a patent, I suggest you do what's called a preliminary patent first, because it's only a couple $100. Okay, and the way it works is you do your patent, preliminary patent, and then you have a year to file for the preliminary patent.
For the utility patent. Yeah, I took some classes on that, but it was saying that he's done with patents and he's just going to keep his trade secrets for his company. Do you have any suggestions on that?
Up my first one, like I said, that first one that I posted what happened is there was some form I filled out where I didn't put the last number, which was a 1. So basically I didn't get any notices. And then by the time I figured it out, it was too late. And so I had to say, okay, I give up. And then I started over. But the second time I made sure I had an attorney I talked to.
It gets expensive.
So like I said, start out with the preliminary because it's a lot less expensive. It's more forgiving.
Okay. Well, thanks for those tips, man. I really love this. You guys, man, you're awesome. I can't hear anything.
Hey, Mike.
Which might.
Michael Boyd.
Yeah, that'd be.
Yeah, I was just a comment on your slides. You didn't show the X and Y axis. So it's hard to kind of understand what the values are there.
The X and Y. Okay, let's go back and I'll let's, and then you can ask me again. Where is it? Here we go. This one or the other one?
Well, actually, all of them, neither one have an X or Y.
Well, the X axis here is time.
Right. Okay.
Okay. And the Y axis is voltage in 100 millivolt. Each of these is 100 millivolts.
Okay. It would be much better if you actually included that in the future, just to help you out here.
Oh yeah, I was just grabbing some random figures off of, and then let's see, the other one was, I think this.
I figured it was an oscilloscope image. So, but it would be good to probably to include
this one. Yeah, see this one. Yeah, I see what you're saying. It doesn't have a XY scale, so it's kind of hard to follow. I see.
Yeah,
yeah, that's a fair suggestion. Thank you for that. I appreciate it.
Suggestion. That's all. Yeah.
Now let me unshare.
I think it's intriguing. What's intriguing to me is that you're taking something that's so ubiquitous and finding a new use for it, right? And then there's this question of what else can you use a hard drive for? Oh, sorry, my video's off.
Well, hard drives for all kinds of cool stuff, you know.
Well, yeah, that brings that to mind, right? Like, what else could you use that as a detector for things? I mean, you know, that's what it brings to my mind is like, okay, if you're able to do that with the spinning platter, and I know that's that's one of your areas of career expertise. And so,
well, one idea I have had is that you have one of these things set up on the surface of the planet somewhere, and then you have one put up in like the International Space Station, and we should get different results essentially depending on where the Earth's gravitational field is, how we could see how it affects it. Theoretically, it should spin. The spin should appear to be a little bit faster than in space than it is here on Earth. So
you could use one of these as a seismometer too, couldn't you? That might be new.
What I'd like to be able to do is measure space-time, have a standard space-time where you can go anywhere. You can go to Mars, for example, and still have the same reference frame, because I think that's a necessity to do what, teleportation requires, that you have a way to convert matter into energy and back again. And in order to do that quantum entanglement, it's a type of quantum entanglement thing. It's like a tunneling. So you build a tunnel between here and Mars, okay? But before you can connect, you have to have an electromagnetic connection. So basically you have to have a transceiver on Earth and a transceiver on Mars, but you also have to have a mass spin valve device, something that's going to convert from one polarity to another for the mass part.
That's an interesting, and you brought something interesting up that I've never thought of before. But as I think Mike and I think several other folks have pointed out, okay, so satellites in orbit, right? They have a little bit different frequency because time moves a little bit different pace. I've never heard anyone apply that to Mars, but the same thing is true with Mars. Time is at yet another slightly different pace there, or really any other gravitational field that you're in. So
right, depends on the gravitational field.
Yeah. So yeah, I think that's a really good point. Finding some standardized way to measure that,
Yeah, universal time. You can go anywhere in the universe, and the clock's still good.
Yeah, well, and again, for stuff like you're talking about, right? When you get into advanced communications, then it becomes more, and I would suppose, so if you're just broadcasting a signal, right, you get a little bit of frequency difference. But in theory, if someday they do come up with some kind of quantum entanglement communications device, if you have communications that are linked in real time between two different time fields, then you'd have to have some kind of a sync between them.
Right. But the other thing is you got to have, going back to the tunnel diode, remember in the tunneling, quantum tunneling, the other side of the tunnel's faster in time. It's ahead of time. It's like that pre-signal thing. So it's like you set up the quantum, you set up the telecommunication port between Earth and Mars, but once you establish the quantum tunneling connection, then things are going faster on the other side. I mean, it may not be a lot, but it is definitely, things are going ahead of time, is my point.
Well, and sir, I may pester you for more presentations on the UAP side of things too, when this report hits, because, I should mention also, I've been talking to Kevin Newth, right, who's been in Jack Sarfati's list. He's been all over that lately. They've been talking about him. And then Robert Powell from, I don't know if you've seen it, the SCU, Scientific Coalition for UAP Studies.
Yeah, it's I've seen their logo on a lot of stuff.
Yeah, explore SC here. I'll paste it into chat. These guys are really interesting. They're in a weird way, they almost seem like the counterpart to what we're doing. Like we're mostly propulsion and a little bit UAPs, and they're mostly UAPs and a little bit propulsion. So, but yeah, they've been ramping things up lately. They have some really interesting materials. And I personally, part of it's just because I'm waiting for this government report to come out, and so I think that'll be really interesting.
When's the 180 days up? December, wasn't it like right?
June 25th. June 25th is the due date for the UAP task force thingy.
Disclosure.
Yeah.
Whatever it's going to be. I think disclosure is actually going to come from a lab where you figure something out big time.
Well, what I'm talking about, it's more like the what is it? Freedom of Information Act. That's
For you.
standard they're using. So when they release stuff, we should expect a lot of it will be redacted. So whatever they do.
Well, part of what I understand from the study that I've done and from everything I've heard and all that is the structure of the report itself isn't going to allow them to redact a lot, right? It's supposed to be open, public. They said they can have they can have a classified addendum to it, but the report itself is supposed to be open and available to the public. But and I guess there are a couple of worries. One of them is they like some of the material that's quote unquote been leaked to the public. It looks like they've got a couple of helium balloon photos. So it's, I guess one of the worries is that maybe it'll just become like a dumping bin, right? And they'll just be like, yeah, we don't know what this is either. We'll just throw that in there, but I think it is interesting. It's a next step, right? And I think it's a big step for the government to take too,
Yeah.
But then I think the other part is they're not gonna, from everything from all the best guesses that I've heard from everyone, people are telling me don't expect ET or anything like that. What they're going to say is basically it's going to be like a book-sized document that says, yep, something strange is going on, Well,
what I think will be cool about it is, there's a lot of people that I know that I can think of, like Hal's name comes to mind, people that former defense or intelligence workers who are all kind of like biting their tongue right now. And I'm feeling hopeful that once the cat's out of the bag, that they'll be willing to come forward and tell us, and do this and participate.
Well, that would be nice. Yeah, that would be nice.
Because that's what we want, is a feeling of openness and trust among the world community, because we're all
Well, and I think they had that article with the guy who's the office that's doing it, right? John Ratcliffe, the former defense,
Oh,
whatever. And he had said, he said that he thought that this report would be really healthy, and I agree with that too. I think, I think transparency about that stuff, it's healthy, it's not healthy to have so many
makes
secrets.
it so that all their stuff that they've been working on for decades, all of a sudden they can get the recognition from the world community for their contributions.
Well, I can sense your sarcasm, but I mean,
No, I'm not being sarcastic.
in a larger, I would say in a larger sense, I think I mean, they don't have to disclose, what I mean? I don't need to know about the latest top secret project. But it would be nice to know, they can keep that stuff in the back room, right? That it's more about like, okay, this phenomena, something is going on. What do you guys know? And, and is it officially going on? I guess that would be nice,
Well, I mean, we could talk about the science now.
Yeah.
That's what I'm thinking is, I don't really care about the drama part. Leave the drama out. Let's just talk about the science.
Well, it's a good point. Yeah. And there are decades of drama. So the other part is, and I'm sure that people will get into that, but when they do get into that, you'll never get the answer, right? I mean, the people who know have passed away from old age. So.
Good point.
Yeah. Well, let me see.
Where's the crickets?
Yeah, we have a lot. I think a lot of people have tuned out for the evening.
What's going on with Bernie Compton? He has some weird lightning going on over there. What is that, man?
Good old plasma tubes.
You got plasma tube. Why do you have plasma tubes? I mean,
plasma ball.
Oh yeah, it's just the toy. Yeah, it's the
The,
plasma.
the toy with your little wireless.
Yeah, there you go. Well, how is that any worse than Jeremy Reese, who's got the same thing on his desk?
Mine's got a Heineken bottle inside it though, so.
Wait.
yeah, I like that. Okay. Is the Heineken drunk yet, or does it still have Heineken in it?
It's definitely ionized.
Well, beer is what built the pyramids.
Oh yeah.
I think it was like ancient aliens or something helped build the pyramids, but they found some records from 5,000 years ago, and they were like pay sheets, and they basically drank. They were paid 4 to 5 liters of beer a day.
They were paid to renovate the pyramids, not to build them. Ever wonder why the oldest pharaoh got the biggest one? Why is that? Because he had to dig it out of the sand and do the minimal work to renovate it. It was already there. They didn't build it.
Okay, who built it then?
It was built by aliens, by advanced tech. Advanced.
I think the odds of beer are greater.
They had some sort of technology that allowed them to build it very easily.
You've got to ask again if the Heineken is drunk or not.
Oh, Will has his hand patiently raised. Will, this is open discussion. You just jump in and.
Oh, okay.
Yeah, just jump in, man.
I just wanted to ask Michael Boyd if how did you make those pits in the hard disk?
On the disk, I use this thing. It's kind of like an electron microscope. You ever see the innards of an electron microscope? It uses magnetic rings and
I
stuff.
use them all the time.
Focus electrons, beam, and makes it so that you can look at stuff real close up. Well, instead of electrons, it uses an ion of some element.
Okay, so ion beam
It's an ion
implementation.
beam. So in this case, the way I made the pits is I used an ion called beryllium, and the device is called a focused ion beam, or a FIB for short, and it looks just like an electron microscope. It's got where the vacuum chamber would be, it's got some gas going in there, I assume, somehow. And so essentially the beryllium it etches. It's kind of like a little ion mill, and it made the little nanopits with that. Now, to make the bumps, I did the same thing, but I used a metal called tungsten, and I used tungsten ion because it's anti-ferromagnetic. It's kind of like aluminum. You can't magnetize it. So, and all the bumps are made of tungsten. So it's like you're sputtering a little square on it. And if you ever used an electron microscope, everything's a little square because that's how it sees. It's like a television, the old CRT television. You know, it's the electron gun going back and forth. That's how the images used to be made before we had all these flat panels and LCDs and all that other stuff. So that's basically what made it was a fib.
Yeah, well, okay, I understand. And but typically ion implantation machines require you to place so you have a disc.
Right.
So how are you doing the whole disc or just a part of the
So
disc?
no, I took the disc and I put it in the vacuum chamber where the ion beam is. Okay, and it's out on a stage.
So you did a section.
This stage was designed because it could rotate instead of going X, Y, it would go, you could rotate it. So we would center it and then we rotate it and then we move the stage X, Y.
That's right.
Right,
And then
the location is. And then when I made my nanobumps, nanopips, I picked a radius.
Right.
And they're all one radius. And if you go back and you look at this stuff that I attached, you'll see the design. It shows exactly where
yeah, very clean AFM images. So that was quite nice.
Yeah. So now what I did is I made the design, and then after I designed it, then I went back and I had to measure all those nano.
Because you had to mark the spot, otherwise you don't know where it is.
And you'll see, if you look at the data table, you'll see that, like I say 40 micron by 40 micron, and it'll say like 40.9 when I measured it. So it wasn't exact. I mean, it's pretty good for considering the dimension I'm working in.
Well, yeah, actually, it's anyway. So, yeah, anyway, it's pretty interesting that you're able to do that. And so when you're but I understand. So you're indexing it while you're doing the writing of the drawing of the parts. Then how do you translate that index?
So I have the location,
the hard drive,
the whole disk in the chamber on the stand, and then I map it out.
Right.
And basically when I do that, it's like I'm using it as an electron microscope. So I can, when I say map it out, I'm using it with the sensitivity of an electron microscope. And then later when I'm actually microfabricating the feature, the pit or the bump, then I've already got it mapped in there, and I can just like automatically move to that position.
All right. Well, that's right. Yeah. So then how do you translate those coordinates to the magnetic disk? To the drive, because it has a coil, and the coil obviously doesn't have the sensitivity of nanometers. So
it's the coils. Well, not the coil itself. The coil, you use the coil to produce the bit on the data on the surface, the magnetic.
Well, I understand that. Coil. So how does the coil?
But when you read it back, with this resistor. The magnetoresistor is kind of like an MRI. You know, when you compare an MRI image to like a normal X-ray image, and the detail is really fine. It can go down to angstroms resolution. So it can see an angstrom, no problem at all, to that resolution. So this magnetic imaging has a much finer resolution than anything else. Now, when you're talking optics, you're talking 700 nanometers. That's like 0.7 microns. That's a huge distance.
Well, yeah, I would, anyway, so but you have to translate the position of your pits, right? To the magnetic head, right? So what is your way? Do you have an algorithm you use to do that?
No, so what I have, if you look at this, these attachments, just pull up the figures and you'll see, and then at one point you'll see I actually take it and I align it to other ways of measuring it, okay? To make sure that, so I don't always just say, okay, this is right, this data is right. I have other methods that are accepted methods that I always compare stuff to, just to make sure that, I'm not just going on.
It is interesting. I should give Will some credit too, because it's 10 a.m. tomorrow his time. So once again, he's pulled an all-nighter with us. So because Will's in Japan, right? So you always have to remember he's like 14 hours ahead or something.
Are you really?
Yeah, he's in Japan. Yeah, it's tomorrow morning his time. That's why he looks a little tired.
Where's your coffee? Where's your coffee?
Well, actually, I have tea.
Yeah.
Japanese.
Yeah, the caffeine, that's the key.
Yeah.
Yeah, you always have to. That's why I always feel kind of guilty when I see him in the conference, because I realize it's like super early his time. So
Yeah, this starts at 4 a.m. my time. Yeah.
No, my wife would never let me get away with that. I mean, you heard her comment last time.
I remember that.
This is what you keep on Saturday.
You have a great wife.
Oh yeah, she's an archaeologist. She's the organized one.
So Tim, did you want to say something?
oh, what do you mean?
Oh, I just thought you were going to close it or something, because it seemed like you were.
Okay, what's Wayne doing?
Oh no, I was actually I was just checking my email in the other window.
Okay.
Yeah. Oh, I see what you mean. No, I was just checking my email in the other window.
Okay.
Yeah.
So
No, I think what he's doing is very interesting. So.
Oh, that is
Sorry,
Wayne's.
somebody else.
Yeah, let's go. Wayne?
yeah,
Is that a
Do-
Campbell thruster there?
yeah, I was just kind of waiting patiently for a chance to blab. I have this idea, kind of relates to Mike's thing with the hard disk, I think. But what I'm doing here is, these are the superconducting wires. I'm just attaching them into this board, and I was going to put another board on top. I don't know. I had two thoughts about this. One was to run a sudden pulse of current through these and see if there might be an impulse generated from that, because of course I'm going to immerse it in liquid nitrogen.
You have a bar magnet or a magnet or circular magnet?
The other thing I was thinking too is spinning this thing at high speed while it's superconducting as well, because I'm thinking there'd be some.
Well, supposedly you can affect the field by using a magnetic field. So if you can change the magnetic, it's basically you can affect the properties with with the magnetic field.
So like if I put a big magnet underneath this thing,
yeah, it might change the properties of how if you like have a spinning magnet underneath it, you might be able to make something spin on top. Because see, the magnetic field doesn't penetrate the superconductor. It just goes around the outside of it. That's
right.
Oh yeah, that's right, because it creates an equal and opposite field that pushes it out.
But if this is spinning, it should self-magnetize all the superconducting material inside because of the Barnett effect.
And then
Mhm.
with that, you'd get also like a nuclear orientation, nuclear polarization thing going on too. I was listening to Ning Lee yesterday and stuff, and she talks about the rotating superconductors and also exciting it with RF and stuff like that. But so I don't know. I'm going to play around with this once I finish it.
Yeah, the thing to keep in mind is I looked at some of her stuff not too long ago. The information that she has or she had is rather dated, and she may have passed away. I believe Paul Murad tried to track her down. She kind of fell out of sight around 2007, 2008, and there were rumors that she went back to China and took her secrets with her. And then there was another rumor that she had cancer and passed and just didn't
That
want
seems
to.
like the most plausible to me, is that she got yanked back to China to work for them in secret.
I think I don't remember who told me this, but if I remember right, the story that to me that seemed the
I
most
think we should
plausible was
listen
that she
to,
got sick.
I think we should listen to Tony because he knows her.
Yeah, no, it's a good point. Yeah, Tony's, yeah, he's a
Oh,
good.
he's right here. He was waiting to talk. Go ahead,
Oh.
Tony.
I talked to a kid about 2, maybe 3 years ago at a conference here in Huntsville, and he said he had talked to Ning Lee about a year or 2 before that. So we're talking now 5 years at least ago, that she was still here in Huntsville, living somewhere here in Huntsville. But since she lives in Huntsville area, I would think if somebody searched the obituaries for Huntsville, if she died, they'd find her. Her son lives in the United States and is I think is kind of a property guy. So he owns property in Huntsville and somewhere else in the United States. So I don't think she would have went back to China unless she was forced. I do know she went back when she had her cancer episode to get some Chinese medicine, but she came back from that. I talked to her after that. But she's quite a bit older than me, so she's getting up in age there, at least 10 years older than I am.
Well, maybe she just didn't like maybe she got tired of the publicity. She was in the media a lot, right? Maybe she just got tired of it.
I have no idea. I know she took a project with the Army after we did the superconducting one to continue some superconducting work, and we heard she was messing with some chemicals that she should have been wearing, like a full garment to protect her, and she was handling it with her hands and got poisoned from that. So, and I don't think I've talked to her since then, but this kid, like I said, at least 5 years ago, she was still here in Huntsville.
So,
You guys have any suggestions on how to measure, like with this kind of thing, how to measure any kind of fields coming from it? Any sort of instrumentation that you might recommend? Or
I mean, Wayne, for me, that looks the closest to like some kind of an ion emitter, but
A Gauss meter.
yeah. From
Gauss meter.
Gauss meter.
Well, that would measure magnetism, right?
Well, that's what you measure. Gauss meter is for measuring magnetism.
that's right.
If for some reason you get one of those higher wires hot, what's in liquid nitrogen, it can actually explode the liquid nitrogen out. So be careful there.
Yeah, the other thing is, Wayne, can you show me your soldering?
Show me my soldering. Oh, I don't know if you can see it.
The other side.
Oh, the other side is just, it's gone through a little bit.
So you're just using typical soldering for electronics, right?
Yeah, lead tin.
Right. Well, that isn't going to work in your project because liquid nitrogen is going to eat that alive. You'll need to use a special epoxy resin, which we use for cryogenic temperatures.
Okay. Is that a
So
conductive epoxy?
it's a conductive epoxy, but it's designed for cryogenic temperatures. If you use regular lead, it will fail and everything will just fall out of your board.
It's
I
like,
use
it's the heat.
indium. Indium works good too.
Indium.
Yeah.
Is indium alone or an indium gallium mixture like a?
There's several brands. You can search it on the web.
I'm just
and-
asking which is better, pure indium or indium gallium mixture, or like I'm guessing it is an alloy better.
They spec it for you when you order it. You look at the spec, and then it'll give you a temperature range and stuff.
That's right.
Okay, cool, thanks.
You know, Jeremiah, I was going to ask, could you use something like gallium instead of the mercury in your experiment?
No, we can't. And there's actually a reason for the variation, I should say, that I want to do. If we're just trying to check for the mass of, or if we're using mercury because it has a high mass and it's also liquid, then yeah, we could use literally anything up to and including water or whatever. But if you want to do what I want to do, which is turn it into a vapor at one point during its state, and the reason for that is I can accelerate that vapor, massively faster. Exponentially faster in terms of its difference in one direction versus the other, its return path when it hits the condenser at the top and comes back as a liquid, or hits the pressure change and comes back as a liquid. So mercury is self-ionizing when you heat it. And that's one of the wonderful things that makes it such a magical liquid metal, or just a magical metal in general, is that mercury at room temperature, because it's way above absolute zero, right? Just at room temperature, a lot of the mercury just sitting in that mercury pool is actually ions, and they're constantly becoming positive or negative charge, and they're exchanging all the time. But the thing is, when you turn that mercury from a liquid into a vapor, whatever was on the surface as far as the state that that particle of mercury was in when it leaves, if it was a negative ion and it leaves the surface, it's going to stay a negative ion as a vapor now, because it doesn't exchange any more electrons with its neighbors. So it'll stay as an ion. If you pass it through a magnetic field, then you can grab the ionic charge off of it and generate power that way. And P.T. Brown actually has a mercury power generator that I was showing the other day in our Vimana research group that I guess I want to mention again if anybody's interested in working on Vimana tech or
So
backwards.
it's running off the mercury ion vapor.
Yeah, the mercury ions can be accelerated electrically, and they act effectively as a plasma. So it allows us to accelerate them very quickly. And that was my thinking, is it gives us another way to get that differential even faster, that time differential faster. And it's just like the gyroscopic drives that we were looking at earlier, or the inertial impulse drives.
Could you
What's
make
that?
a manifold for that? Some kind of
Yeah, it has
manifold?
to be.
Like
You have to.
the old two-stroke engine?
Well, it's flow manifold. So what it does is once it goes into the vapor state, you want to confine it down to a more narrow pathway so that it accelerates. And that's going to push it into sort of a beam. And then you can use electric charges or external magnetic fields due to its ionic nature to accelerate it even farther beyond that point. And then when you want it to recondense back out, so it's under high pressure, it's still really hot from the boiler. All you have to do is open it up into a wider manifold, which will automatically drop the temperature because of the pressure change. And in that way, you don't have to take much thermal energy out of your system, which would of course be wasteful, because then you're just having to run more energy for the heater, and there's no reason to waste the heat.
So a manifold with a water radiator.
You could use a water radiator, or if you design it with a wide enough change, so it goes from a very thin tube during the acceleration section to a very wide tube, that pressure change may be enough under the right conditions to recondense it back into a liquid so it can return slowly. That would be the goal, is to have it automatically happen with very little temperature differential. So it doesn't actually have to hit a condenser per se, it's just the vapor on its own. Once the atmospheric pressure changes around it, should automatically recondense, or at least that's what we're hoping.
That doesn't sound dangerous at all. So let me
Well,
see.
it's
You've
all
got
close.
boiling mercury vapor traveling through a tube with a water condenser.
Doesn't take that much heat to
Oh.
boil.
Right, exactly. It's boiling, but it's boiling at like 95 degrees Fahrenheit. It's not really boiling like, you're not going to get burned by it. So
No, it's the mercury vapor part that makes me nervous.
well, the good thing is it's only a vapor because it's in a vacuum. If you break the vacuum, it won't be a vapor anymore all of a sudden. So
And of course, we have a professional building this for you.
no,
Hopefully you have a few.
Do you have a death
but I have
wish?
professionals that are capable of at least instructing me on it. And I have worked quite a bit with lab glass in the past and dealt with high pressure chemistry of volatile substances. So I'm not super new to the idea of keeping a substance sealed into a vessel and making sure that it stays there.
Well,
I do
but
take
at least
pretty
you
big
have
precautions.
but at least you have a flow chamber or something to protect you from the gas.
When we build the full size machine, we'll be building an enclosure just specifically for it that's pretty well sealed. So, but we're just talking about the concepts mainly right now. These are just ideas on how we could do it or how we might do it if it's even possible. I see Mike Gamble's stuff and I see the Thornton drive and I see the Brian's work and I'm just thinking to myself, there's got to be a way to do that with something else that's a little more linear and it just doesn't have that cogging motion. It doesn't have to row in space. There's got to be a way to do it. And if this stupid brain could just figure it out, some way.
I think that's,
Jeremiah.
I think that's a valid
I don't
thought.
want you to get hurt.
I think,
agree.
I think that the idea is you're trying to, oh God, what, you're trying to make a generic version of the effect, right?
Right, I'm trying
And
to build
Mark, yourself and Mark have talked about this many times with angular momentum, with the NMR experiment, translating angular momentum into linear momentum on like an atomic or molecular scale. And so, you know, so it's in a weird way, it does, a lot of these paths kind of diverge back, or they converge back to the same destination, right? So I think it sounds like you're trying to make a generic version of it. You're saying, well, okay, if this works, then how can we make a more generic version?
Right. How can we simplify the idea down to something that's easily depictable in a single animation, a single graphic, so people could understand and comprehend it?
And it's interesting having it go from vapor to liquid also. I'd almost wondered it. I was wondering about tunneling diodes, and like I lack the terminology to explain it well, but I did wonder, you know, you've always got action and reaction, but what if you're able to take part of that reaction part and move it to a place where the particle doesn't exist? If you have a tunneling diode, now, I don't know. I guess there are a lot of questions. Does the particle not really exist, or is that just a mathematical, you know, fake for something that happens with holes? But
It's more of a mathematical fake. I mean, the particle doesn't actually cease to exist, regardless of how much quantum physics would have you believe that it does. It fails in a couple areas, and especially when it comes down to modeling wave functions with a reciprocating charge, for example. It'll miscalculate the position of that charge and guarantee that it's not in a certain location where it has to pass through. So can't trust it completely.
It works real good with electric.
Quantum physics says that, yeah, it's a matter of probability of whether the of the location of the particle. That's all it says.
Right, exactly. And in one of those examples, say for example, you take a box, you take or a square enclosure, and you bounce a particle back and forth between one side to the other at a constant velocity. Inside this box, it bounces and loses no momentum. It just simply changes direction. So bouncing back and forth between one side and the other, if you map its probability of being in any particular location from left to right along its path in that box, the probability function will tell you that it's a 0% chance of ever being exactly in the center. And of course, we know that the ball has to go through the center. We know that it actually does. And if you watch it with your eyes, you'll see that it passes through the center and that the probability of it passing through there is 100% because it's moving. But like I said,
you can't know that.
But you look.
You know its position. And if you know its position, well, then you don't know its momentum.
Okay, and this is where you see the mathematics diverge from reality, and you have to ask yourself, should we really trust the math that can't predict this clearly obvious flaw correctly?
Well, what it is where our basic theory of the particle being a particle is incomplete because it's not a particle.
Well, it's either a particle or a wave, or it has attributes of both.
Well, and then here's the issue, right? Because everybody wants to use the excuse, well, this is on a super small scale, so you can't really apply the same logic to the large scale with something like a billiard ball. But I'm like, yeah, you can, because as we keep on finding out with quantum physics, you can make really, 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 really big molecules. Now we have over 100 atoms in a molecule. We can fire that through the double slit. We get the same wave interaction. So it does work on a macro system, and there's no reason it should be violated. So
yeah. And you can't see the particle nature in the double slit experiment unless you put a sensor at one of the slits. And then then you'll see each photon appear. You know, like, wow, look, I saw a single photon show up on the pattern screen, right? So it is if you can measure the position, then you don't know the momentum. If
But
you
you
don't,
have-
Getting called for dinner. I think
Well,
I'm
you
gonna
have to measure it
I want
without
to
looking.
come back. I hope that this is still going when I come back. I do have to take a quick
Yeah,
dab.
you know, speaking of which, what I can do, maybe I could make, Mark, are you going to be on for a while? Should I make you the host?
no, I gotta go too, guys.
Oh,
Yeah, you can make me the host. I'm here.
okay.
I invited Aton to come on. Did he join us yet?
Okay. Oops. Okay, here, more, I'll make. Okay.
Woo, I'm the host. Yeah, great.
Yay. Yeah, it's still, let me see. Yeah, it's still recording fine. Okay.
Oh, guys, by the way, this Cinco de Mayo, the May 5th, there's the meteor shower. I forgot which one, but it's supposed to be a little stronger this year. So if you're up at the
Like
wee
that.
hours of May 6th, there's going to be almost no moon, and you should be able to see like 40 of them per hour.
Didn't they say that in that movie that just came out, the Greenland movie? Doesn't that how that starts? If I remember right, his buddy's telling him something like that. Yeah, meteor shower coming up. It's supposed to be a little stronger.
Do you know what area of the sky it's gonna be in?
At around 3 a.m., it should be straight overhead.
Well, let's just hope it
Where are
hits the
you at,
building.
Yeah, 3 a.m. and the moon's rising at like 3:30, so you get a pretty nice view if
You're
don't
on
have-
the East Coast, right?
Yeah, we're on the East Coast. Yeah.
Okay.
So what about northwestern Canada?
Listen, it all depends on your weather.
That's true.
That is always rule number one for sure.
Actually, our weather's pretty nice out here. Bernie, are you out in your van?
I'm in Calgary, Alberta.
Oh, well, that's not really northwestern. That's, well, I guess sort of kind of, should be clear in Calgary, right?
It's supposed to rain for the next 2 weeks.
Oh,
Okay, then you don't have any sky.
we have rare sunshine out here in Seattle.
That's right. And
Here's the weather just above Seattle.
oh, very good. Nice.
Nice and sunny.
Yeah. Yeah, Wayne lives, actually,
So-
Wayne probably
See
lives.
the meteor shower at 6 a.m., right?
Yeah, I mean, it kind of peaks at around 3 a.m. because that's when the Earth is traveling. That's when the sky above you is traveling the direction the Earth is traveling. So around 3 a.m. is the peak.
Your
Local time, no matter where you are then.
So I have to get up at 5 for work on that day anyway, so maybe I'll go see.
Well,
That's May 6th. That's the morning of May 6th. The night of May 5th, morning of May 6th.
well, it's great that it's 3 a.m. because that's when the Earth's magnetic field is weakest. So we can get better penetration of the meteors.
That's interesting. Wonder if that really like makes that much of a difference because they're usually not metallic anyways, are they? Or maybe you want
Although they're very metallic,
Yeah, they are. A lot of
lots of iron in meteors.
not all meteors are metallic.
yeah, some are carbon.
Made by aliens.
Yeah, we've got some Martian meteors too. Remember?
Yeah.
Oh, to get back on the measurement problem. I hate to change the subject, but you know, those little particles are always jiggling. You know, they're always jiggling. Even at absolute zero, they're still jiggling. So how could you measure? You can measure when it hits the target behind the double slit because that's where it hit, but it was still jiggling. I'm still flummoxed on the idea of momentum.
It
Or-
behaves differently the closer you are to the slit. And there's what's called near field effects that you don't really see when you look at the pattern. If you if you move that screen up closer, you would see something totally different, because there's also the near field effects that you don't see, and because you have interference effects that you don't see at the far field.
Well, I think he's probably referring to the Einstein-Boyson state, but actually NASA or some university, I don't remember actually, to be honest, had developed a quantum trap, and using lasers could actually freeze the atoms of some element, which I also don't remember. So that was actually interesting, because there is no wiggle room for those atoms. They're just trapped there in space.
That's
So-
amazing.
Oh, I think I know what you're talking about.
And they're very cold.
They have a thing. Have you ever seen a particle chamber like they use for like particle accelerators? It's like this kind of, it looks kind of like a fog chamber, and then you can see the particles trajectory
The
show up.
Cloud chamber.
Cloud chamber, yeah.
So you see a positron curves one way and a electron curves the other way.
Exactly.
Yeah, I had a question. I had some ideas about that, like the spin direction on an electron and the spin direction on a positron. If they spin opposite directions, could they be like annihilating? Because if they're equal spin and they're symmetrical to each other, would they just lose their energy in the vacuum when they?
In the atom, you have two electrons of opposite spin in a covalent bond, for example.
Okay, so they can spin opposite directions, just electrons.
Coexist.
Michael,
together.
is that opposite spin or opposite rotation around the nucleus?
I don't. What's the difference?
Well, maybe it's spinning
So,
in.
I mean, it depends on the type of orbital, obviously. You have s orbital, which is like a spherical orbital around, like in energy levels, kind of like one of the other speakers was describing with the gravitational field. And then you have like p orbitals or d orbitals that look kind of like loop-de-loop. And they actually tunnel through the center or through the proton radius and come out the other side, the opposite spin, kind of like the two jets in a black hole, for example. They're of the opposite spin.
I did hear a new theory from twistor theory. It was on Jeremy's channel. These guys were talking about. Some guy mentioned twistor theory by Roger Penrose. Do you know anything about that?
It's a vortices theory. I don't know the specific details, but I
Even Roger Penrose didn't know that much about it, but he thought that it'll be a whole new physics idea. Get away from string theory and go to twistor theory.
Well, that'll be funner.
Yeah, I think I like twistor theory. It goes along with I like spinning things.
Remember the game Twister we used to play?
I still have that game. I still have the
Great
game.
card game. You gotta get the adult version though.
Yeah.
That's a lot of fun, actually.
Okay.
Jeremy, maybe you could tell us about twistor theory, and he also has Phoenix theory. We got lots of theories.
The Twister theory.
Yeah. Why not?
Well, I got to sign off, folks.
Yeah,
I'm actually
I'm
on
gonna go.
KP. I'm on the Admiral has me on KP, so
I'll leave it going, but yeah, I have to walk my dogs and get dinner for the child too. Well, it's a great conference, guys. I'll leave it going, an open discussion, but
Yeah, I'm gonna
Thank you,
end
Tim.
end the live stream now. Can you guys hear me?
Yes.
Yeah, we can hear you.
Yeah, I was talking, but you couldn't hear my microphone apparently. But yeah, twister theory, that's Roger Penrose's idea. And then this new stuff came out, this newly declassified Project Twinkle. The Air Force was, I guess, looking into lights in the sky from 1949 to 1951 and collecting data on lights in the sky. I haven't dug into it that much more than that, but I'm going to check that out too. It's something new that just came out, so we'll check it out.
I really enjoyed your talk, and then with Skylar, I think Skylar is his name. He was telling me,
Yes.
he was instructing me about all these different ideas that still work other than what Einstein thought of. You guys work really well together. I like the I like the synergy, the way you guys work that. I forget what the podcast was. I think it was the last one you did. At least the last one I saw was great.
Yeah, we're just trying to put all these pieces together, the technology, all that stealth blimp technology, and on the Lake Marabou stuff with the light craft, which looking for stuff that could be a precursor to, more advanced crafts. Like, there's a lot of people that think the Tic Tac is ours, and it's a classified program. So just trying to piece together as much, puzzle pieces of what we have to try to figure this out. Again, there's guys that came on the conference today and were assuring us, knowing that it can be done and that it has been done, and we're encouraging us to continue along this path. I think that this community is going to, if we continue doing this for the next, 2 or 3 years, we're going to have a major breakthrough somewhere along the line, or at least get more serious people on board who can help us to make that breakthrough.
Well, it's great synergy. Great synergy.
Absolutely. Thank you all for watching, and thanks for everyone taking part, and feel free to join for the after party. We're going to be hanging out, but I'm ending the live broadcast now. Thank you all, and smash that like button, and don't forget to subscribe.
Goodbye, everybody.
Bye.
Good night.
Bye, everyone.
Sweet. All right, so the broadcast is over, and but we can still hang out, and
So, sorry, I can't. Jeremy, right? Hey, this is Will. Hey, I was, I'm not on your, what do you call that, on your list for when you have your presentation. So I don't actually know when you're doing it. Can you put me on your mailing list?
sometimes I just go live randomly, so I don't have like a set thing, but and I don't have a mailing list yet. I'm trying to get more organized with it and do set up scheduled streams and stuff. But sometimes we'll just be, sometimes I mean, every night I'll be on for a little bit, and I'll get a bunch of people on a Zoom call, and then every once in a while we'll be like, all right, we got to go live and talk about some of the stuff, and that's what we'll do. So it's just not. It's not like super planned out ahead of time a lot of times. So sometimes it's spontaneous. So I wish I could give you guys a heads up. It helps if you have a YouTube account and subscribe to my channel and have that bell ring, because that will send you notifications and email notifications when I go live or when I'm going live. So, but yeah, sorry about that. We'll just be having a meeting and decide to go live randomly. So
Okay. Well, yeah, it's just I'm in Japan, so it's a little bit difficult to. Our timetables are slightly different.
and
So if I had a heads up, then it'd be easier. That's all.
yeah, and anyone on here that wants to have like an individual kind of podcast thing, something a little different than this, not so rigorous, if they want to come on my podcast and be a guest, feel free to email me. I'll drop my email right now in the chat, so people can get in touch with me. I would love to get any one of you on, any one of you guys that want to come on and do a show sometime. We'll do like an hour and then open it up after an hour. Usually what I do, I try not to go over 3 hours, because the streams just get a little bit too long and crazy for people to watch. But that was good stuff.
Sorry. Yeah, so I've looked at a couple of your videos and they look interesting. But in general, what is the real core theme of what you're doing? Because your name is kind of broad. So I'm kind of, what do you usually talk about?
Mostly it's been like, lately it's been a lot of UFO and alien stuff, but like every once in a while we'll dive into like some, alien story or a conspiracy topic or a conspiracy story, and we'll do like an overview of like the kind of evidence and the best, I try to get like, my thing is like, I know when I find people that seem like they know what they're talking about. A lot of people do know what they're talking about, and I like to have experts like that to come on and give different perspectives on different things, especially when there's science involved, because there's a lot of conspiracy theories and conspiracies out there, but not very many that you can actually use the scientific method to really, try to analyze them with scientific tools. So we kind of try to have people that have tried that or attempted that from different perspectives and get different. It's about getting information out, and information that's, I started getting into this stuff like 10, 15 years ago and realized how easy it was to, manipulate public consciousness and change the public narrative and take a hold of topics and really, mislead the public and mislead people into what's really going on. And so it's kind of been a quest for me to get, a clearer narrative and a clearer perspective on the truth. And it doesn't, and I often doubt stuff that's in the mainstream when I see, them talking about anti-gravity and, these other scientists, who aren't doing the research and aren't, participating in the community, basically sit on their platform and down talk everything that we're doing and trying to do. And from their perspective, and I try to understand those perspectives and different people's perspectives and share, and also share, as expert as perspectives as I can find on different topics. So, but yeah, I've lately the focus has been primarily on the tic-tac stuff, the technologies, declassify, all the stuff that's come out in the last 3 years from FOIAs and declassification and covering that kind of stuff and bringing people up to speed, because they're all sitting there waiting for the next leak or the next big thing to come out, and they don't realize that there's still so much information they don't even know about that's already declassified that they just haven't had the time or patience to dig through and look into. So,
well, it doesn't help that there's a lot of people out there with misinformation themselves, trying to get on, places like you to mislead people as well. So
yeah, there's that too, and then there's people all over the media and stuff, and I've been a victim of that too. Where I think I'm right about something, and you find out you're wrong, and you get different information. And there's a big battle, because it's like, well, what's misinformation and what's disinformation? So
right.
I'm just trying to report on what I find, but you get this misinformation out there, and you repeat it on your platform, and now it's, and there's stuff like that with that where we make mistakes too. I made a mistake. I said I accidentally mentioned the George Hathaway replications of the Pod-Foot-Knob experiment, but I didn't. Like I said, they were successful, but they were not successful. And so like I make a slip up like that on a stream, and it's like, oh God, that's crucial, because now when people watch that, they're going to be like, oh well, you made a mistake, and it's not like I wasn't doing that intentionally, to disinform people. I just had wrong information at the time, but
Yeah,
this is good getting these experts together, because you get people like Glenn come in here and give us the straight story on Ning Li and Pod-Foot-Knob and some of these other characters, and that's important, because he's a source that's reliable and an expert that you can actually trust. So it's reassuring when we get.
Yeah, those people have pretty much irritated the heck out of me as well. I don't like it when I run into those people, but like you, I have also run into those people as well for disinformation, misinformation. However, if you make a mistake on your podcast, one thing I've noticed that some people do is they'll put a note on the bottom of where they were talking, Like,
Yeah, you used to be able to add these annotations over the podcast, like an overlay screen. You used to be able to
right.
do that, and I don't know if you can still do that on the video. I think they took that away because I used to
Oh,
do that all the time with my old videos. They have the annotations that would pop up and stuff, and I don't know how to do that so much now. They changed a lot of stuff, so
oh, I see. Well, anyway, just putting it out there.
yeah, no, I get it. I usually try to correct it in the next video if I slip up and make a mistake, but again, we got to put together these summaries because a lot of people are just diving into this and they see all these streams that I have that are 3+ hours long, and no one's got the patience for that. Let's be honest. So I want to put. I mean, we do because we're into this stuff, you know, and but I want to package this so that we can get the best information and the right information out to people so that they can stop spreading.
Yeah, sorry, Jeremy, I don't mean to cut you off, but just see that point you just made there. It's just don't do like these 4 hour long. What you're better doing is all these guys, you get multiple podcasts you're able to do and have a back and forth over maybe the tops an hour or 30 minutes. 30 minutes would be even better. You
Yeah,
could bang out a bunch of them. That would be a lot more appealing to a lot bigger audience. And right, so my background, I was on the original team for Isaac Arthur's channel, the pre-production team. So it's like I'm kind of looking at this and going, look, well, we can do this in a different way.
definitely.
Yeah. Yeah,
Yeah.
people really don't seem to have activity in their memory. What is that? That's so funny.
Heck is the stream link?
Very interesting.
But I definitely think the channel should be a bit more audience focused, like as well. Like, well, maybe not even this channel, maybe another channel. Maybe the idea is to get another channel. I don't mean that against you, Jeremy, because I know that you've been the one that's been pushing us the longest.
I've thought about it, especially now that I'm getting better equipment and a better setup. I'd love to do something like more professional and journalistic, and especially now that we spent 10-15 years sorting through the muck of all that misinfo and disinfo, and we actually
Yeah, but
got
a lot of it comes down to it's not the information itself, it's the presentation of the information.
It is it's the sleek 1080p 4K video, and the music and the editing and the cuts and the cool graphics and high definition graphics and photos, all that. It's a lot of work. These movie producers that do video, they charge like $300 a minute, for the final product. It's like just for editing, because it's so much editing. You literally sit down, you're editing.
No, I know. I mean, like I've paid, me personally, I've paid 2 TV series from home. So I get sent the hard drive with the raw footage. I paid 2 TV series. So that was like, 13 episodes each. It was like 26, 28 minutes, whatever it was. But you would cut that down because it's the same intro graphics and shit, and like outros and stuff like that for adverts, and it would all be synced up to certain points. That was my job. Just my industry collapsed because I was subsea. So I spoke to Jeremy about this before, like I do subsea tech.
Yeah, I'm gonna try and get more people.
But I just think definitely the main thing that I'm thinking about is how do we get the science out? You know, I'm like, right, well, it's not even how do we get the science out, it's how do you, this needs to be an industrial scale project, because the money that's involved in like little projects is not going to cut the money that's needed to actually fund these projects for experimentation.
Yeah, I hear that. There's got to be some way to package this and popularize it to bigger audiences and get more people interested and involved with this. I feel like once we have a facility like set up, like this has been my dream, is like a stream house or like a ranch. If someone could set up this spot, and we've talked to a couple people to set a place like this up, and if we could set that up and bring, you know, get everyone there. And
I think getting everyone there is the hardest part.
The thing is about it, though, it's like,
yeah,
just now it's not really about like, the thing is about it is trying to go, how do you monetize it? But the good thing is you've got a YouTube channel and you can monetize it because you're doing media. Because if media takes off, but it's just how it depends how the media goes. Do you know what I mean? How you present it and how the audience takes it in. I mean, it's like the channels that make money are bullshit on YouTube, and it's all fed to you as well, and everybody knows it.
oh yeah, the biggest UFO channel, Secure Team 10, and you know, what the biggest hoaxer out there, and he's made all of his following and all of his money off of doing hoaxes.
Hey,
I just think
I'm back.
Yeah, Jeremy, I think one of the most irritating thing is we always have people who are always talking about, you know, how if you do this or you do that and whatever. But the problem is that I see that there's no doers. There's only people reporting what other people do, who usually never even show up. Or like, you know, we found a UFO, we have this material, but so what is the material? You know, what is it actually, you know?
Oh, send it to the army, and
So
the
you
army's
always
got
have
it now.
But I don't think we can.
these
I
are
don't think we can
all-
even take it to that point of view, because what's the point of having it to that point of view? We need to start from where we are starting, not where someone else is.
Yeah, huh?
Well, what's the point of trying to say, oh, but maybe the army's got this tech and they're going to declassify it or whatever? But it's like, well, that's all well and good. Even if they did have it, they wouldn't give it to you. So if not, you need to learn it yourself. So it's like the thing is about it. It's that's the bit that worries me about this stuff. Is that the thing is we're always going to. It's always as if the technology is behind a paywall and it's not something we can achieve on our own.
Got to be reproducible by more than one person.
Oh, it was not
100%, yeah.
reproducible, it's not scientific. And if it's not scientific, it's not technology, so.
Nope, it's magic. Or it's video editing technology and tricks off camera.
The thing is about it, it depends whether you've got someone like you can afford to pay to do more. Well, I don't even think it's about pay. I think it's about like getting someone that's into it that's going to cut up some stuff. Do you know what I mean? I think it's developing a format, to be honest with you. I think the format's important. And then if you look at a lot of channels, and I don't know. I don't want to say too much, to be honest with you, because we're thinking about, you know, Jeremy's channel and stuff like that. Just like, well, I don't know, like, because it was like you said the other night, you were like, you got 105,000 subscribers, and you had like 300, you had 106 people watching or something. You know?
Yeah, it's the topic too. Like we did another night, we had 600 people watching, and it was like when that triangle story was really big. It was well, that story was still fresh, and a lot of people were searching for stuff on that. And I titled the stream like about the triangle UFOs and had a picture of it, and that for some reason got more people clicking on it and checking it out than any of these other. It's more, I guess, it's more applicable to a larger scale audience. Whereas, you know, 6 times the people can, sit there and listen to us talk UFO stories and talk about UFOs, but only one in 6 of those people can sit through, a lecture with equations and math and
Well,
throw in
no,
science.
but I think that's the thing. I think what you need to do is split the channel so it becomes like see if it became
Yeah, it's like my
Patreon
wife
based.
says, you got to be a geek.
See if it was Patreon based. I think that would be the way to go. So what you do is you basically say like, see these long haul conversations. The main channel is focused on like kind of punchy videos and interviews. So you can do like, say you create something and go, here's a presentation and like, 60 seconds or 3 minutes or whatever, or TikTok, it's 15 seconds. The public's attention span now to get people's attention is like seconds. And I worked in media and stuff like that, and it's like, see now, I look at it now in 2021, in the middle of COVID, to go, oh my God, do you know what I mean? The media manipulation is just incredible. But it's like people have been taught at universities and media studies are how to control people. It's been done for years.
Well, I guess ultimately it really means, Jeremy, know your audience. So.
Yeah, 100%. But it's just, but expand your audience is what I'm saying. But I don't know what's going on with your channel. Sorry, because it's like that.
Yeah, I definitely. I'm going to take a little clip of that.
What is this? What's Burns Eye Mind 3 up to?
Yeah, right.
What is that?
What's Bernard doing, man? He's going to give us some demonstrations in his lab.
I don't know. It looks like some voodoo experiment to me. Strange brew.
What are we cooking?
So some folks were talking about ether or vacuum energy, and I caught this interesting. I'm going to share this thing. It's there we go. This one. Okay, where is it now? Physicists prove, can you guys see this screen here that I'm sharing?
Yep.
Okay, physicists prove that imaginary part of quantum mechanics really exists. And
imaginary part.
And international research team has proven that the imaginary part of quantum mechanics can be observed in action in the real world. For almost a century, physicists have been intrigued by the fundamental question: why are complex numbers so important in quantum mechanics? That is, numbers that contain a component with an imaginary number I, or the square root of -1. Usually it was assumed that they are only a mathematical trick to facilitate the description of phenomena, and only results expressed in real numbers have physical meaning. However, a Polish-Chinese-Canadian team of researchers has proved that the imaginary part of quantum mechanics can be observed in action in the real world. We need a significant reconstruct our naive ideas about the ability of numbers to describe the physical world. Until now, it seemed that only real numbers were related to measurable physical quantities. However, research conducted by a team of Dr. Alexander Streltsov from the Center for Quantum Optical Technology, QOT, at the University of Warsaw, with the participation of scientists from the University of Science and Technology, China, USTC, in Hefei, in the University of Calgary found quantum states of entangled photons that cannot be distinguished without resorting to complex numbers. Moreover, the researchers also conducted an experiment confirming the importance of complex numbers for quantum mechanics. And the article describes the theory of measurements have just appeared in the Journal of Physical Review Letters and Physical Review A. So, but basically what's, if you think about, I'm trying to think, just thinking out loud about some examples of real examples of quantum of complex numbers is impedance. You know, electrical impedance uses complex numbers. Dielectric constants involve complex numbers. Another example is this antigravitational energy is hyperbolic, which would mean, and that means it's a third order polynomial as opposed to parabolic gravity, which is a second order. So since it's hyperbolic, that means it has one real and two imaginary factors. That, you know, what I mean by factors, you use factors to solve, you know, like a quadratic equation, for example. So it's kind of cool to think about. Can you guys, any of you guys think about any of the stuff that you've worked on where you actually had coming across stuff that was only described mathematically using a complex number? I'm just curious. I hear crickets. No. How about any thoughts on the quantum vacuum or vacuum energy? As far as Einstein, I heard some folks were criticizing Einstein or saying he was old hat or whatever. And I actually feel like a lot of Einstein's work is actually his wife's work. Because you know, she was his first wife was a physicist too, and she was actually better at math than him, I hear. Any thoughts on Einstein's wife?
I've read that, yes. So some people have, some books have mentioned that that as a fact. Yes.
Well, I know my wife's a lot more organized than I am, so.
Yeah, I think it has to do with the time, right? So
Right.
during that time, you know, women were dogs. Now the men are dogs.
Oh, men are what?
Now the men are dogs.
Yeah.
But back then, the women were dogs.
I'd rather think I'm a house cat myself.
Oh, that's a good idea. I like that. That's a good one. No, but seriously, back then in Einstein's day, you know, women had were lower in society, right? So they weren't supposed to be smart like him. So
Well, they didn't even have the vote until the 30s in America. So, I mean.
So women had a really hard time in those days. So victim of the time, I suppose.
Yeah, it's sad, but the point I'm trying to make is if there's any problem with his theories, it's not his fault.
That is an interesting point of view. So
get right. I tell you what. Right, here's something. Right, just out of interest as well here. Who has any actual real evidence, any kind of mass reduction experiment?
That's what?
Oh, we're the ones working on the mass reduction. Me, Wayne, and Todd are working on the dynamic nuclear orientation stuff,
Yeah.
making coherent matter states.
Well, I'm not with you in that. Like, I'm not like a science-based guy. Like, I'm a kind of more engineering focused guy, like manufacturer focused guy.
Okay.
So
yeah, I mean that's
so,
pretty much what it is. It's not really
yeah,
all that number stuff that you see and all the math. It's there's
exactly.
very little of it actually makes it into the lab. That's all
Yeah.
theory. And to be honest, there's several theories on how this experiment would work if it did work, and many of them are not mutually exclusive, meaning that they could sit there arguing until they're red in the face after it's already working about which theory is correct. You know, and
I understand that. Yeah.
there may or may not even be a way to distinguish which theory was correct. You know.
No, I know, but the thing is, we need to look at like it's how do you make something from its starting position gravity neutral? So some kind of system that's involved in its center of mass that is gravity neutral. So when it starts its own place and you can slowly maneuver it. But you don't want it to be too strong, it starts flying for everything either. You don't want it to be a hard satellite.
Mm-hmm. Yeah, it's a good point.
All I'm trying to say to the group is like, because I'm not part of you guys, I'm just an outsider, do you know what I mean? I follow Jeremy's channel and stuff, but like, how do you take what you guys are doing, particularly the math guys? I totally get it. I was pretty good at maths, you know, and it was like academy, but it's like, see now, it's like I'm not like, I'm not using maths. I do hardcore engineering, but it's like I don't use maths because I'm a practical guy.
Okay.
No, but what I'm saying is, it's a problem for the audience to listen to it and go, "Oh, I get this," because it's like a hour-long documentary about like maths that no one understands. So I'm just saying, put that behind a paywall is what I'm saying, because it's more something that people will pay for rather than the other way.
I'm against putting anything behind a paywall.
No, but I'm saying, like, if Jeremy's trying to monetize the channel and try to make it professional, but I can understand that. But I know you guys are trying to do it for free. I'm not getting that, but I'm saying, like, for the channel to be more popular, and make it more viral. Like, I see the paywall thing, totally get it. I know where you're coming from, but I'll make it a separate channel, I guess. Paywall is the wrong way to put it, I guess.
Yeah, I'd agree with that. Jeremy, I think he's talking for you for this paywall idea. What were you talking about? What's this about?
That he's monetizing it.
Oh,
yeah, that's the way I would say it, is monetizing. I'm not trying to say rip anybody off, but Jeremy's put a lot of work in, and as you get paid off.
Jeremy's not, he's muted.
Your lips are moving, but we can't hear you.
I've been working with a guy who's a web designer to help me set up monetization for my channel. It's not, first off, it's not a paywall. I don't want to set up. I want to set up just ways for people to donate and contribute and have a membership thing and get on a mailing list and have insider updates and invites and stuff. Patreon is like PayPal. It's like, we're trying to find something that's not a third-party app that I can just take and process credit cards directly, so I don't have to pay some middleman to do basically nothing, and then a middleman that can shut off my funding flow if they don't like what I'm talking about, or they just, their advertisers or someone else in their business doesn't like what we're talking about.
Definitely a Bitcoin donation.
So I'm trying to find a place that something that we can do to get monetization, but it's like they've literally gone through and destroyed every way. They must have financial people that sit around and like plan this stuff up and like and figure out.
The ones that are made for you.
What?
They're not as perfect because I had to make them.
Oh yeah.
I don't know who's talking, but They should be muted. Who's
I
host?
think it's Wayne's the guy
Yeah,
that's
for-
live.
Okay.
Everything's a middleman, and there's always a middleman. It's got to be Patreon or PayPal or one of these other guys, and they take like 9% of all your money, and then they can shut you down if they don't agree with the IRS can come in and shut you down. They've already moved to like take out the Bitcoin thing and tax people for the Bitcoin. And
Are you trying to operate as a nonprofit?
I am a nonprofit right now. I haven't
okay.
fucking jack shit off this. I put all my money and all my work into
Jeremy,
doing this.
talk to me about this offline, but I have a nonprofit that I could sponsor you. I've sponsored other nonprofits. So
I need someone who knows how to do this stuff.
Can I just come in there?
Done it
with this
before is what I'm
non-profit idea?
saying.
No, can I just come in there with the non-profit idea? I definitely think that what you're doing is definitely not for non-profit. Because if you come in at that point, then you can get the rug swept straight away from under your feet. You want to be going, we are making this for profit, investors could come in. Because if it's real, but the thing is, it's like there's some things I won't say, but I think that it would be a good opportunity to invest in this kind of technology. But that's as much as I'll say.
Jeremy, I'm just trying to say I'm willing to help if you want it.
Thanks, man. I need a
but-
lot of help, man. I've been looking into this for a week now. I meant to do it last week and set this up, but everything I run into is just a stonewall. It's like these financial institutions have literally conspired with each other to prevent,
Yeah,
it's they're not gonna,
you're right. I empathize with you. Just I'm not afraid of them. I've sued the banks before too. So my nonprofit's been around since 1999. Okay.
I need to learn more about this. I don't know enough, and I need help. So
I'd be happy to help.
All right. I'm set up and I'm here and I'm present. And hello everyone. I am Bernard. And I am Bernai, the mind's third eye science guy. And I have decoded and reproduced Sir Isaac Newton's alchemy transmutations, as well as figured out that it is electrolysis, cold fusion, that is the process. And here are
Process for what?
For cold fusion, for the alchemy process of the 7 states of metal element transmutation. Also that monoatomic or GANs or ORMUS white materials, that is your plasma state metal elements. So it's the 4th state of matter for metal elements, where ionized gas is the noble gases, 4th state of matter, metals, and it's in Sir Isaac Newton's writings stating this.
Talks about plasma?
Yes. So plasma is the 4th state of matter, and we've only really understood ionized gas as a plasma, and that's noble gases that exist like that in their plasma state. And it's that metals break down to a single atom solid, but they lose all properties of the solid metal and then gain this plasma superconducting, weight loss, over unity principles. And if you rotate them at very high RPMs, they produce this superconducting. If you have them at absolute 0, they do the superconducting. So if you have them rotating out in space, you're going to get very large plasma fields generated by them. And So on the left side of the burn eye, you see the blue and green coil, and then you see the blacky red and blue one. They are the exact same copper, exact same lines, just the blue green one is the anode, and the black red blue topped one is the cathode. And what I've deciphered with ancient alchemy is that they understood this plasma state of matter much better than we did. And that's what their flame is. It represents plasma. Your earth is your solid, your water is your liquid, and your air is your gas. Plus the fifth element, that is plus your periodic table of elements. And what's crazy is the geometry of like witchcraft, esoteric, alchemy, and whatnot. I have no understanding or following of the spiritual alchemy or any of those studies, but it's just the geometry of their spells is identical to how the same geometry works in forming crystallizations and breakdowns, as well as the creation of all physical solid matter and how things react in the electrolysis cold fusion reactions. In electrolysis, you're producing atomic hydrogen. When you get a metal into its seventh transmutational state, the crystalline state, where it's pink and actually crystal reflecting light, and you put in the right resonant frequency of the metal that you want to transmutate it to, and have all the properties right, that is how you are then able to merge the atomic hydrogen in with the solid metal, creating a new element and atom that materializes and crystallizes out as your third dimensional solid. As well, it produces deuterium and heavy water. We all know that the key to nuclear reactions is heavy water, and then in your centrifuges, you're rotating. So fusion happens in salt water that is rotating with anodes and cathodes. I've got years and years of work and discoveries and understanding that I'm only now starting to publish. But
Bernie, do you have any experiments that you can talk about to support your conclusions that you've told us?
Oh, absolutely.
Well, can you tell me one example or something? If
so,
you don't have to, I'm just curious.
So what it was is that I first heard of monoatomics through David Hudson and his Ormus. And then I did the 2 years online with Nassim, and have met him at a couple of his conference and his research, as well as following Dan Winters and his research. And then
I know Dan.
I've been participating in the Keshe Foundation workshops for the last 9 years, and I've been experimenting myself for 6 or 7 now. And it's that when I was doing AC current electrolysis with different anodes and cathode metals, trying to produce Keshe's GANs, gas, atom, nano, solid state. So just a different acronym for this plasma state single atom of metals, is that I then read Sir Isaac Newton's alchemy writings when it got first released a few years ago, and things started to make sense in that the results I was seeing from my experiments with the Keshe stuff was describing exactly what Sir Isaac Newton was describing, as well as all these other alchemists were describing.
Bernie, I'm curious. I never heard of that what you just mentioned about his writings about alchemy. Is that something that you could provide a link to, maybe in the chat?
Absolutely. It was first made public or published to the public for the first time in history 3 years ago. And then the site that I reference is, I'm gonna look it up. It'll take me a few minutes. I'll do it, post it at the end, but it's one university somewhere in the States, and it's their website and translations that
I'd be very
it's based
interested
off
to
of.
see that. That would be pretty exciting to see something like that.
And it's my thesis is that this monoatomic plasma state nanoparticles could also essentially be your quantum state matter because of quantum entangling. And have you guys ever heard of the famous nuclear chemist, something Moon? I'll find his first name right now. But he's like he was the world's leading chemist for a long time, but he has a theory that particles and electrons and atoms take shape and bond in double geometric structures. Thus, when any metal oxidizes or forms a 2-atom particle, it interacts as a solid and has its solid properties. Thus, this single atom pure metal plasma state unbonded is then that with the mathematics and everything have to be filled in, but just that it could potentially be your physical quantum stuff. And I also experiment with lots of different coils and windings. Sorry, lost my train of thought there. Okay, so this white jar here in the center, where it's got that black circle, that is silver. It is hooked up to the cathode as well as a copper coil.
Bernie, are you trying to show us something you see on your screen? You could share
it's
your
on
screen.
my second computer, or I have 2 links into this Zoom.
Oh, I see. Which one is it?
Bernai, the mind's third eye, science guy.
That's really cool. Now I have the context of what you're talking about.
Sorry, I should have explained that better from the get-go.
And these are the cache coils, right?
The one on the 2 on the left, the blue and green, and then that black and red one, those are the Magrav coils. The one in the middle is a different type of winding that I've come up with on my own, and it's actually I didn't know it at the time that I just started doing it, but it's wound in the same way that the moon rotates around the earth, that the earth then rotates around the sun motion wise. I haven't run current through it or anything like that. I just found that fascinating after I made the link between the two. But so it looks like transmutation between the 2 different parts of the anode and the cathode there. And it was in the crystalline state beforehand. I have pictures of and video of the whole experiments that I'll be posting later. but for the present time, this big jar, it is making copper, zinc, and silver. What I'm saying is this monoatomic metals of all three. And all metals, when you do the process properly, will turn into this same white fluffed stuff, or turn green or blue oxidized if you do it wrong, or it'll turn yellow when it's in the transmutational state and you disconnect the current. Everything in the entire water jar and molecules instantly turns yellow, which I'm theorizing is sulfur and transmutation straight into sulfur, as well as that gets into this red state, which they claim is this mercury state. And who knows if it is a part compound that transmutates into mercury bonds with these other metals, but all metals also simultaneously turn into this red crystallized matter at a certain point in the process as well.
When you say crystal, do you mean like a amorphous solid, or one that's actually a crystal, like
so the outside of the winding turns to this it's not like it's like a milky bright pink, but it's bright in that there's thousands of shimmering crystal reflections off of every part of it as you move light around. And it's the alchemists that stated, as Isaac Newton did, of the seventh state being crystalline. And just in my own observations have found that there is this state that it reaches, that it reflects light off of everything. And it's crazy.
So have you tried experimenting with using light when you're using light in the process, or like shining bright lights or anything like that on it? Because basically you can control the reaction optically so that your crystal takes, so basically there's ways they use, there's certain materials where you can like change the color, and it basically changing the crystal orientation because the light looks different because the bonds change. The distance between the atoms changes. So basically you've got a cathode and an anode, right?
Yeah.
And you've got an electrolyte, right?
Yeah.
Electrolyte is what the react, like in your lead acid battery, you have hydrochloric acid, for example, is the electrolyte, as it's called. You get the charges from somewhere. So all batteries are basically a cathode anode. It's a leaky capacitor. That's the way I describe it. It's like a capacitor, but it kind of leaks. Puts out a lot of current quickly.
Oh,
so,
yeah.
So you thought about that?
I've had jars of just like the monoatomic at the bottom, and then I have a copper coil on one side going halfway down, copper coil on the other side going all the way down. So creating anode, cathode, and measured 7 volt steady continuous coming out of it. And I checked it for like 6 months straight. Every time I'd check it, still doing 7 volts until I just forgot to put more water in it and it dried up it and whatnot.
No, but you're not having it continuously discharging. You're just measuring it every so often. So like when I measure something with my
I've had them with like LED on it, like continuously going sort of thing.
Oh, cool.
I've also had it where I've wired just straight copper coils and then plastic copper wires, 3-phase from the top to the bottom. So essentially, the one on the very right with the yellow lid, it's 3 copper coils within each other on both the top and the bottom, and then I have coated copper 3, one connected to the middle piece of copper spiral, one connected to the outer, one to the inner, going to both of them, and it produced an electrolysis cycle continuously for 2 weeks now. I've had it
Wow.
sealed, and all it is salt water and copper. So colloidal silver, lots of people have heard of that.
Yeah.
And structured water. So colloidal silver on average is 8 to 16 parts per million. This monoatomic is essentially 1 million parts per million. And when you wash all the salt out, I rinse it 9 times, and then each time I let it sit for a day. And then after letting it sit for an additional day, I drink the top part of the water, and that is colloidal silver, zinc, and copper, and it's exponentially stronger than the regular colloidals. I don't actually ingest any of the monoatomic stuff ever, just the structured water.
Well, thanks for sharing that stuff with us, Bernie. That's cool.
Most definitely. Nice talking to you guys, and I'm also working on a new geometric dimensional shaped unified relativity theory based off of lots of Isaac Newton's work, but also Pythagoras's the octaves and the Platonic solids.
Platonic? You mean like Platonic relations?
Platonic.
Like the flat universe?
Like polyhedral combinatorics.
1D is the disk. 2-dimension is a pole connecting. So 1 is your electron field, disk, light, gas. 2 is a rod connecting the 2. That's magnetism, polarized opposites with 2 fields. 3 is the sphere, which contains gravity and volume. And then 4, tetrahedron, cube for 5, essentially, and then keep going up and up and up.
You broke up there on 5. What was 5 again?
5 would be your cube or
cube.
Yeah, the cube.
Isn't that Phoenix? Isn't that the same as Phoenix theory?
No.
So 5 is 4 was tetrahedron, 5 was cube.
Whatever the Platonic solids are in order, starting.
I got you. I got you.
And then
starting in what order though?
So
the order by the number of faces or the number? I mean,
yeah.
So you have
at 4D with the tetrahedron.
This is Nassim Haramein stuff, right? With the nest and Dan Winter stuff with the nested polyhedra.
So the nested polyhedron thing is the moon guys theory and stuff, which fits into it, but what I'm talking about is different, but it does fit into the standing waves formation between the different dimensions, and it fits into the octave scale. A lot of it fits in with Walter Russell's work, and what's key is Walter Russell's transmutations of all the noble gases in the vacuum tubes, as well as a lot of his octave diagrams. And
yeah, because there was some connection they tried to make between these Platonic solids and the orbital levels and atomic nuclei.
And it's the ancient alchemists that their symbols.
It's the ancient alchemists that thought of this, but I think it's wrong. I don't know. Is it?
But what I'm saying is, like, I've been decoding and reading the ancient alchemists, and I've been connecting it in with
what modern quantum field theory.
Well, well, just a lot of where I get is the real verbs, Jason Verbelli.
Yeah,
He-
yeah, yeah.
he's
I gotta get him
brilliant.
on.
He's right on
Something.
par with me. I've been talking to him. If you could get both me and him discussing, like, guarantee you within 6 months someone will figure it out.
I just I'm curious about all these guys.
thing.
And then you said you spent 10 years, you've been following this Kesh Foundation for the last 10
I've been
years.
participating in the live streams weekly for the last 9 years.
And what is
I've never joined the Kesh Foundation, so I don't have
like
any
me
insights.
coming from like a technical and make kind of a mainstream physics background. I kind of approach that stuff. I've seen it. I've watched a couple of his things, but I'm like, I can't get into it because I don't see enough connection. Like a lot of these guys, I don't see enough like.
Right, they turn into cultists. They talk about spirituality 90% of the time.
Yeah.
And it gets lost in translation, right? Big time. So
I'm trying to understand that stuff, but I can't. I don't know. I don't always know.
it's frustrating.
I definitely want to talk. I definitely want to talk about that when I bring you on the show, though, because it's interesting.
Is nano coding and the breaking down into the plasma and stuff, and like
he uses a lot of these words and talks about a lot of like modern technologies and stuff, but I don't see like. I'm not convinced that he's actually producing these things or doing them at his foundation and with his research and stuff. Like he uses a lot of like examples of
I've watched them progress, and it's like I'd say
I haven't followed him in about 4 years.
30% of what he says is like actually the case, and then it's like he's also just trying to make it up as he goes and stuff. But he's developed a lot in Iran. He developed a lot in Italy, and there's videos of him doing disclosure with the Vatican with like some high up, dressed up fucking dudes in robes and shit. And it's like he's been protected ever since. And then he spent the last 4 years in China, where apparently they put a whole bunch of money into his shit. And now he's been based in Australia for the last year, and their group in Australia.
He has really good marketing. As like one of the things that I've noticed from him, he's really good at marketing himself and production and stuff like that. Something I could learn from. Definitely.
And there's millions of videos of other people reproducing the stuff and doing the actual teaching of how to make it, and that's what kind of like got me into being like, this could be legit sort of thing. Is just there's so many different people, and it's that it's cheap and easy, so you see it in like third world countries. And now after watching them for so long and watching them progress and develop, it's like they have made major advances for sure. But as for if he actually has anything that can fly to space, I have no idea and highly doubt it. But
even just like writing what I want to do, like where I'd like to be in a couple of years is my goal is to take people like you who are discovering things potentially, right? And I want to help you with the part that I know a little bit about, because I have a bachelor's degree. I had to write a couple of physics papers for experimental physics classes and stuff. And my goal is to get our stuff published, and start publishing our stuff somewhere. You know what I mean?
Can I ask you something?
That's the next step, I feel. And yeah. Who you talking? Are you talking to Jeremy or Bernard?
No, to you.
Yeah.
So how do you deal with the funding? Who's funding the research?
The issue.
We're funding it ourselves so far. With, I just been funding. I've been funding all this, my YouTube channel and this with just, this is just me and my hobby.
Okay. Jeremy, I just messaged you on LinkedIn, just so you know.
So also right now in the chat, I'm posting a link to my most recent presentation and interview. And it's really well done. It explains things pretty good, like overview all in all, and the host does a very good job of editing and putting up good reference pics as well as asking the right questions.
Yeah, I've gotten a couple debates with Jason Verbelli too. I got to get him on because it's like he likes to, like, anytime Einstein's mentioned or any of this stuff, he goes off like but I really
Okay.
like.
Another major part of my relativity is also adding and like a 3D sphere, three-dimensional sphere, and then your one-dimensional moment of time, like time being a page of a book being written. And that's how it's infinitely thin and whatnot. And then as the universe travels continuously, think of a book flipping through all of its pages, and the moment of consciousness being that cartoon picture that emerges into the moving.
So I can kind of picture that in my head, and this goes back to what I was really fascinated by Tony Robertson's kind of interpretation of general relativity, and he set up this whole scheme of like these those recurring wave orbitals that just extend out into infinity, and that kind of that's like the generating function for what space-time is. And I love that kind of analogy, and that actually is closer to what Phoenix theory does. So what Ken Griggs did in that first paper that's published on the Hubbard Brothers theory page, I'll post a link to the paper right now so people can check that out. And because there was a question about Phoenix theory earlier, and this kind of like that analogy you just made really makes me think about, this whole idea that Phoenix theory had for what space-time is and how it's constructed. And I just was amazed at how similar, the version that Ken Griggs described to me of that was to, I don't know why my site's not getting reached. I can't get to the site.
Are you bringing Ken Griggs on?
No. Oh, you know what? You want me to bring Ken Griggs on? I'm going to send this. I'm going to send him a link to this right now.
So 0 and 10 essentially are the torus, and it's binary. Everything starts out binary, ones and zeros, but your 0 is also infinite within its defined God, sorry, lost train of thought there. There's the word infinite, but defined at the same time, right? Like that's the seams part put into it. But the one being the straight line, your electron, but from another dimension being that disk plane of the electron field. And as it kind of goes back into essentially the Sumerians and their different types of mathematics. And sorry, I've got a lot of work to do on putting the presentation together, but
yeah, get it all out in slides and try to be as clear as showing, what the mathematics were, I don't know, because I want to know more about that stuff, because one more interesting, and it's kind of
part I have to talk about the alchemy, so the moon is silver in ancient alchemy, and when making monoatomic silver, like I've had silver cathode, silver anode, and I've had it running for 6 months straight, and literally the amount of monoatomic plasma silver being produced in this big bucket would wane and wax and grow a lot as the cycle of the moon went along. And one time there was a super moon, and it completely filled this tub that never got more than maybe 10% full of this stuff on a regular full moon, filled the entire tub overnight. And it's like when the moon is at its weakest, there's like 1% overall, like barely hardly anything being made, and it directly correlates to the moon cycle.
Well, that was interesting what someone said about the Schumann resonance too. I forget who it was that mentioned that, like that these space capsules have this thing that produces that artificial Schumann resonance, and that our bodies will fall apart if we get away from that. That was wild too. That guy that jumped in.
I've never heard of that before. I'd like to see some
yeah, I'd like to see
supporting evidence for that claim.
Schumann is one of the
Indeed, there was a lot of claims made by that individual. I want to see. I'm interested to see more supporting evidence for. So,
how much research have you seen into the Solfeggio scale frequencies? Because the Schumann is only one of 7 Solfeggio frequencies.
Well, they were talking about several different harmonics from that 7.3 hertz, 7.38 hertz Schumann resonance. It depends on which one you're talking about, but they were all, as I remember, less than 30 hertz.
The key is to know that the Schumann resonance is part of the Solfeggio frequencies, and there's 7 of them. And I'm currently about to make a video with a researcher out in California who's been studying it and done experiments for decades. But through coils and putting the different Solfeggio frequencies, he said like they've got documented evidence of it directly physically affecting people. Like one frequency makes you sick, one frequency makes you euphoric, one frequency makes you instantly angry, one frequency makes you instantly happy, one makes you like beyond depressed. And that they've had it where they were inviting random people in and like recording the like not knowing and just putting these frequencies on, and you'd see the emotional reaction in these people with
like A minor is always a sad song, and D is always like a kind of a happier, D major is always kind of a happier tone.
But they wouldn't be hearing anything. It would be just going through the coil, and it resonates through them. Like they didn't even know that these frequencies were being played or could have any like recognition or understanding sort of thing, like, so it
has to be resonating though, because you understand, like, if there's a resonance at a, is it a multiple of these other frequencies? Because they've got to be, like,
you said he had 7 of these
if it's not an audible range, is it
yeah, so you can't hear it, it's just being pulsed through these coils, but it's like you'd see in the video like someone turning it on, and then like the random test subject having no idea that it was happening, just being triggered by these emotional responses as they'd go through the different frequencies.
I guarantee you it was studied by the MK Ultras Project 68, which I covered in my UAP briefing presentation. So they did a lot of research.
If it could upset you, they've already figured it out.
Yeah. So I swear they do it through my headphones sometimes. As soon as I take them off, the headache goes away.
You got to go into one of these RF. So like I do my communication stuff down here in the basement, where there's not what I call electrosmog all around. But if I go upstairs and I do it, I can hear like the tick tick ticking on my audio. You can hear that if you put your speaker from your computer next to your router, it'll make a noise. That's the
like
RF.
when I have my cell phone on top of or close to my my input thing or my speakers or
feedback resonance.
Yeah, exactly. That's the 2.6 gigahertz or 4 gig or whatever it is. That's what it sounds like.
Yep.
So
And
But
that
in any case, yeah, I like
burst
the-
transmission, you can hear like the burst transmit, you can hear like the bursts because it's burst transmission on the signals. It's like these
yeah.
pulses. So you can
But
hear
there's
like
places you go, like if you go out, I live in Santa Cruz County. So if I go way out in the mountains where they don't have any cell towers for miles and stuff, total radio silence. It's different. No cell phone signal.
right. Well, they talk about those. They have that one show on with the people that hear that noise no matter what. And they brought them down to those places. There's like these old mine shafts that like, there's no radio waves there at all. So like, but they still hear the noise. They said it's stronger down there.
Where they go, another place they go is where they have these big radio antenna arrays, because they're so sensitive to radio frequencies. They don't want any radio frequency sources around. So a lot of people, they look for those areas where they have those radio telescope antennas that they use, because they can't have any noise for like so many miles around them.
That's true. Yeah. Well,
I have one of the groups that I sponsor is called stopsmartmeters.org. And in California, the local utility here, Pacific Gas and Electric, decided they were going to charge ratepayers. I think it worked out to about $4 billion to install these things called smart meters that they could read with, fire their meter readers and just do radio, RF, wireless. And supposedly they sold it to us so that we would be able to track our usage and see, see what the price was. So we could, do demand response, it's called. Well, the reality is it doesn't work that way. You can't get a read from the real time. You can only get it from the previous day. So, but there were all these people that were all upset because they would get sick. They put these smart meters in their home, and every 10 seconds it would take a read, and it put out a significant, like, we're talking watts. And that's a lot of power for RF sources, a watt.
Yeah.
And so,
that would cause enough, interference noise on a radio antenna that would mess up their signals, what they're trying to pick up from space. So.
There were people that, nobody wanted to touch. It's like talking about 5G or COVID vaccines, they'll shadow ban you, right? So that's basically what, nobody would sponsor that group. And I said, oh, we'll sponsor you.
I learned that lesson. I haven't touched the Corona thing on my channel, because when I covered 5G, I was just making videos investigating all this stuff, and I was talking about MK Ultra Project 68, and I was talking about ICNIRP, that organization over in Germany that does all the testing on these devices.
TUV.
ICNIRP. .org.
Huh.
They had a whole publication. It was the best find you could ever imagine. It was like a whole list of all the bad frequencies and all the papers that told you how to do them all and everything, all in a big document. And it talked about the microwave auditory effect, the voice of God stuff, and all that other crap, which I had put in my.
It's pretty shocking when you hear about it, but we don't want to talk about that.
Well, hey, it just apparently there was just an attack on the White House like a month ago or something, and it wasn't made public right away because it was still being investigated, but it came out.
And who are they blaming? The Russians?
Probably.
I don't know.
Who's this Burn Eye Mind's Third Eye Science guy?
Oh, that's
Bernard.
That's
Bernard Conkin.
Oh, it's a second view from Bernard.
Yeah, Bernie's doppelganger there.
Is he gonna make us some gold like using lead, or is?
I'm pretty
Yeah.
sure I have once turned a little bit of tungsten into gold.
What do you
Yeah,
turn
that's right.
tungsten into gold?
Tungsten into gold, really?
Tungsten. I want to see some red mercury.
We
swear
already
to God,
talked
I
about
have
mercury.
red mercury compounds. Like I got fucking jars upon jars upon jars.
No. Red
Some of the
mercury.
best
Me and
form-
Jeremiah were going over this. Red mercury is not a compound. It's an energy state of mercury.
No, see, it's not the pure red plasma mercury. It is other elements that in their transmutational state, one of those states, the sixth state, is the mercurial state. And what I theorize is that this transmutation out of the electrolysis water process creates mercury out of copper, out of zinc, or creates it out of nowhere and bonds to it in these compounds. The red part that is
You can
formed,
show me a repeatable
all
experiment.
metals turn into this red stuff.
You can show me in a repeatable experiment where we can do
Jeremiah has some real mercury here. Jeremiah, can you unmute yourself and
That's what I want to see.
talk about
This is
mercury?
fantastic claims, but
Let me get my
And I don't know if it's true or not. I'm going off of the writings of all of the ancient alchemists, and this is what they say, and then what I make appears to look to be the same thing.
Okay.
Mercury. There you go. That's mercury. Jeremiah, what did we learn about mercury this week?
Oh, I can't give away all the secrets here, but boy, did we learn a lot about Mercury this week.
don't give it all away. Don't give it all away, man.
Keep your secret sauce, Jeremy.
Well,
the
we want to
secret
release
sauce.
all that secret sauce in one big burst to kind of like, blow it all out of the water all in one shot. So we learned enough where we think we can hopefully soon do a demonstration of what's probably been identified as red mercury. And that will be very, very interesting. So
Nothing is added.
It'll be the first time on video, I think maybe almost ever publicly shared. I've never seen a video ever of the actual red glow. So hopefully we're gonna be able to show that on video if we can get an ISO that's high enough.
Yeah. And if we can get that linear accelerator.
Still don't need that for the red mercury.
Well, it makes it faster, doesn't it?
You need a linear accelerator?
A line act. Yeah, it would speed things up.
Halted specialty group. They used to carry the old one, some of the old mini ones from Stanford. Slack.
Huh.
Slack.
How much do they go for?
Yeah, I think
10 grand, 20
half a
grand.
mile long.
You might have to.
You can get one for 10 to 20 grand.
Yeah, you'd have to shop. You'd have to look. I don't know. I haven't looked in years, but they had one for like 12 grand, but that was over 10 years ago.
I think the prices.
I don't even think they're at the same place anymore. But yeah, this is in Silicon Valley, so.
They came with the magnetron and everything else, or
There's one up in Middleton, Mass. that MIT runs at the Bates Research and Engineering Center.
Yeah, that's the other thing. You could buy recharge time on
Yeah.
an existing one. That would be the best way to go.
That's
It'd be a
probably
lot
the best way to go.
cheaper.
Yeah.
I think that's cheaper. That's probably a better option. It's
Jeremy,
local here.
about that. We need to find the closest accelerator to New Jersey.
Oh, he said there's one in Massachusetts. That's not so far away.
Well,
Yeah, it's a little
New
bit.
York.
It's north of Boston, a little ways. It's like
You.
it's north. It's like a little bit north of Salem. It's not quite to Topsfield or Newburyport, but it's up there.
If there is one in New Jersey in this area, we can go check it out. It's not something that I'm like itching to buy and have in the lab. It's
What experiment are you trying to do?
we're trying to energize mercury, bring it
No,
in.
there's nothing down near there.
Line act, Mark. Now, okay, well, again, we had talked about a possibility of needing a line act to make some exotic materials, particularly materials with charges that are embedded so deeply into them it would be virtually impossible to do it chemically or any other way. And the idea is that if you can trap charges in a material, Richard Van Derrick's method about having particles of metal inside of a epoxy mixture and just allowing the electrons to tunnel out of those particles of metal through the epoxy is great because it allows you to get lots and lots of charge trapped into a solid material. But just imagine, you have a really good insulator and you can just get the charge permanently trapped in there.
So have you considered using ion bombardment? That's what they used in semiconductors in the old days. They would do ion
Talking fairly
bombardment.
thick materials, not like changing priming a P junction or an N junction, but maybe a material that's say 1/2 inch thick, for example, or something like that, where you'd really want to get charges deep into there. You would have to have a huge amount of velocity to do that, and you probably won't be able to do it with just ion.
So now when you're making this dielectric material, is it a liquid state?
No, it's in a very solid, very contiguous state with no structural defects, or it would not be able to withhold the electrons that have been embedded into it.
Okay.
Have you ever rotated mercury at high RPM?
Nope, only at low RPM so far. We've just dabbled with the idea of magnetically coupling to it without any contact, and so that was pretty successful. It's actually very, very easy to use MHD to spin mercury around, but we haven't.
I think we should invest in a glove box and a vent hood if we're going to be doing that experiment.
100%. Yeah, we are gonna get that. We're gonna get one of those.
Yeah, definitely. I had a friend when I started talking about this video. I went to one of my roommates was literally doing mercury experiments in the kitchen, and it like sprayed mercury everywhere. And I'm like, dude,
They eat mercury.
Is he acting funny yet?
oh yeah, he's been acting real funny ever since. I just was like,
Yeah.
he's like, why are you taking it so seriously?
No, it's serious stuff.
I put on a
No,
respirator.
I remember
had
when I was a
gloves.
little kid, I'd put it in my hands and like roll it around. I thought it was really cool.
Oh yeah, I had a bunch of it in a container when I was a kid too, because we broke a thermometer and it was a bunch of it.
Oh, you gotta love it, man! You gotta love it. I had a bunch of it too, and I was a little kid, and then I asked everybody else I ever knew for the bunch of it that they also had, and collected it in one place. So that certainly is one way to get it. Just ask everybody.
Yeah. When we were out in Colorado, we went to we were calling around places for mercury, and these people said, yeah, we have 880 pounds of it, and you're welcome to come and grab it all. We'll give it to you for free.
What? I wish.
Wow.
It was at a waste dump.
So how much does mercury cost a pound now?
1 second. Did you get the 880 pounds of it?
No.
So where can we get that?
Yeah, you probably call toxic waste and hazard places because they collect all the old mercury stuff,
They won't give them to you. They can't. They're not allowed to.
Not anymore.
You guys
Right now,
see,
they say they can't do it for some legal federal reason. But we are good friends with a lot of YouTubers who have hundreds of pounds of mercury. So
Yeah.
Chain of custody. They have to maintain the chain of custody.
It's all right. We could pull some
you
strings.
guys see the picture
I
that
know a
I'm
guy.
sharing on Burneye?
Say again. What was that, Bernie?
yeah, we see your giant container
The
with your,
spiral.
yeah, we
So,
see the spiral in there.
Another thing I've noticed and continuously observed is that these monoatomic plasma self-organizes and always, what does Dan Winters call it? Like, also like the Searle, like the cold, not implosive, but implosive technology. It always implodes into a central point, and it doesn't matter. It forms several layers, like electromagnetic layers within the water, as it self-organizes and as it implodes into the center, and it will move on its own for days. It's not.
That sounds like deposition and co-deposition. Are you familiar with those terms? Or
No.
so if you're running an electrolysis through like a solution like that with dissolved particles in it, and you're going to get deposition of those particles onto the surface.
Like it's that it will form
Same kind of thing that like metal plating. and coatings, happen.
9
So.
distinct layers within the depth of the water that only certain it's weird, like they'll self-organize and move in opposite directions or be suspended animation, and you'll have particles moving between from top to bottom with the oxygen and the bubbles that go up, and it will not disturb or affect the flow or the rate of these independent levels.
Yeah, I'd be curious. So what's have more experimentation and what's going on in those levels and layers.
Gerald Polak, or who's the guy that discovered the water exclusion zone?
Polak.
Polak. I've
Yeah.
also got lots of documentation of that happening, but it breaks down into layers of that happening throughout the depth of it. But it'll be particles, and then it'll be just a millimeter of pure water, then another type of the same particle, and about an inch, and then the millimeter of pure water going through. So it's like it turns into several layers of battery or capacitor of electromagnetic fields and charge.
Let me ask you this.
Riken, can you post a link to that in chat, please? Yes, thanks. Oh, there he goes. He already did. He's on it.
That was fast. Have you ever seen the behavior reported about monoatomics where they repel themselves from a magnet as if they were diamagnetic?
Yes.
And of those, which monoatomic elements seem to behave like that? Do you know? Or could you have a magnet around? You could actually.
Here's the thing: is that I have only really majority messed around with aluminum, copper, iron, a little bit of gold, silver, and zinc, because the heavier, denser metals, they're depending on voltage, depending on interaction.
Bernie, I wasn't asking you for a complete list. I wasn't asking you for a complete list or a breakdown of all the materials that do this. I was just asking you of what you have personally seen.
But this is, you gotta listen to what I'm saying, because each group of metals, it comes down to like Walter Russell's octaves or the octave system, and Walter Russell's like diagrams of the vortex-based periodic table, and that they interact in both the sections of each octave as well as the section of where on the octave chain they are, if that makes sense, like you can graph out, and that's how you observe the properties of them or how they form properties. So the one that's copper, silver, gold, iron, which is also the alchemist's metals of the solar system as well, the soft metals, they pretty much lose all of their magnetism. Even iron loses its magnetism in this form, and it's the heavier, bigger metals that have those effects in dielectric interaction. So I don't have any personal experience with.
That's do you have a magnet around? I mean, do you have a fairly powerful magnet sitting around your place somewhere?
Yeah, I got magnets around some of them and stuff.
Yeah. Would you do me a tremendous favor, just because I've never seen it ever, and I've only heard only heard rumors of it? It would be wonderful to actually see some of this monoatomic stuff repel a magnet, either while it's in suspension in water or.
No, that's what I'm saying. The metals I'm using don't have that effect.
Oh, they don't have that effect. Okay, yeah. If you do ever see it, please take that moment to videotape it, just so there's at least some existence somewhere of a video of this actually happening.
There, we got diamagnetism over here. Guys, we're joined by Eitan Suchard, who has actually done several videos on warp drive and several other topics. Eitan, Shavua Tov, welcome.
שבוע טוב ומבורך.
Well, welcome to APEC. I'm the only one here that, other than Eitan who speaks Hebrew. So
Yeah, well, took me time to get on that line, and I didn't even know that you're here. What did I miss until now?
oh, what did you miss? You missed a lot. There was 3 speakers: Tom Valone, Gamble, and the guy from NASA,
Tony Robertson.
Tony Robertson.
Yeah,
Yeah,
he showed a really cool way to get relativity from quantum mechanics, and it was really neat. I
And then
loved
me
it.
and Jeremiah were talking. We showed another video that Jeremiah sent me a video this morning about this device with gears that created.
Give me a second, please. I have someone who's ringing the bell. Just give.
Uh-oh, they found him. They found him now.
Yeah, they got him. He was just here for a minute, and that's
State
it.
security.
So
Listen.
the picture I have up right now is of that silver, and that amount of monoatomic silver being produced around the anode is the moon at about 3/4 full. And the one time it was the super moon, literally all the blue oxide, and because I also have copper around this silver.
Why does the moon make any difference?
Because in alchemy, silver element is the moon, and the what I'm saying is I've done physical experiments with ongoing for 3-4 months where the amount of silver being produced was directly correlated to where the moon was in its cycle. When it was black waves, there was very little. When it was full moon, it was producing the most amount, and when there was a super moon, it filled this entire thing. So normally there wouldn't be any blue oxidization in this monoatomic silver production, but I have copper also touching the water with this silver.
Is there any
Do you have that data somewhere?
Oh yeah, I got the pictures. I'm cycling through it. I'm gonna show you guys.
That's awesome. You know who else mentioned a cyclic tendency to track with the moon? Thomas Townsend Brown in his lab notes.
Yeah, but that's
You know what it is.
As well as Ed Beats Allen.